dictionary, and this dictionary will have two keys. The first one will be the name, which is a string, so this will be the name of the object, and the next will be a CF, which stands for C frame, and it'll be fine. So we're going to use a keyword type. We're going to say type object saved onto a database. So we're going to say local function serialize plot is going to have a plot, which is a model, and it's going to return the data type that our serialized plot should be. So let's actually define that. So we're going to use a keyword type. We're going to say type object info equals a dictionary, and this dictionary will have two keys. The first one will be the name, which is a string, so this will be the name of the object, and the next will be a CF, which stands for C frame, and it'll be an array of numbers. And I'll explain why we're doing this a little bit later, but let's actually serialize it. So we're going to first define a data table, and this will be responsible for holding all of the information for every object in our plot. So basically the whole idea is we want to iterate through every object. So we're going to say for object in plot dot objects get children. We're going to iterate through every single object, and for every single object we're first going to get the C frame, the object CF, which will be equal to plot get pivot, and we'll convert that to object space for the object get pivot. So we have to take the C frame of our object and actually convert it to local space, or object space, whatever, to our plot. Because remember, when you leave and join a game, your plot could be a different point in the world. You don't want your objects to spawn in the same spot again and again because you might be different. So we just save the position relative to our plot, because the actual part should be known relative to the plot, not to the world. And so now we actually create our object info. So we're going to say local info is an object info of type, and the name is just going to be equal to object.name, and then the CF. So you may be thinking, how are we going to convert a C frame, which is an object and it has different properties, whatever? How are we going to convert that into a like format that can be saved, because like when you deal with like data stores initially, like, oh, they can only save strings and numbers and like arrays, stuff like that. And a C frame is an object. We can't just say like, okay, like here's a data store, or like please just save the C frame. Data store will not do that. But a C frame is actually just a matrix. So it's like a 3x4 matrix or something. I don't know. You can look up the documentation for more information on that. But basically, if we do table.pack object cf get components, we can basically say, so get components returns the 12 values. Wait, I think, yeah. So it's, yeah, here we go. So it returns the values x, y, z, then the rotation values, and it returns that like each value as a tuple, whatever. And it's just a long list of numbers, and we can save numbers. That's exactly what we want. We can save numbers. So we're going to store these in a table.pack. So it'll take all of these like individual arguments and turn it into a table, or array in this case, and save it to C-frame. And we can actually save that to the database. So that actually works great. So when you're serializing something, you just want to take all of the actual like components that are like raw, like data values, like, primitive types, like integers, strings, whatever, and save that. So if you're saving a color, for example, you can just save the RGB values. Where C-frame, it might not be as obvious because it's a bunch of different things. But if you look at the documentation, you can just see it's just a bunch of like values and a rotation matrix. And so like for stuff like vectors, you just save the 3 vector values, or you can even save like the magnitude and direction. I don't know. You can do whatever you want for that. But in this case, this is all we need for C-frame. So this saves the rotation and the position just like that. And so after we create the info, we need to do table.insert data info. So basically, we're going through every object, we're serializing the name and the C-frame so we can later put it back in the game, and we're putting it back in the data. And then at the end of it all, we just return data. There you go.
What?
So that's actually the magic behind the serialization. So now the rest of the stuff that we're going to be doing is like, kind of defensive programming, kind of getting all the things saved properly. So let's go. And first of all, we got to get the plot manager. So I'm going to say local plot manager equals require script.parent.plot manager. And now let's go fill out our save method. So it may seem plot manager equals require script.parent plot manager. And now let's go fill out our save method. So it may seem kind of weird to do save before load, but like kind of logically it makes sense. Just like for the purpose of this demonstration to save stuff before we load it, because you can't load anything if it's not saved. But let's first start by getting the plot. So local plot equals plot manager dot get plot, and this will take in the player, which we can just send in again. And so we obviously have to get a plot, and if the plot doesn't exist or not plot is descendant of workspace, then we gotta return it. So basically, if our plot, like, if it fails, there you go. If our plot fails, meaning like the plot is actually like not in the world or it just doesn't exist, we have to do the second check for is this descendant of workspace, just to make sure it's actually in the world, because there are some edge cases where this like might not be covered. Then we just abort early. And also, this is kind of an oversight, actually, when I was writing the script for this video. This probably shouldn't be the case. Whenever you return early like this, especially when you're decreasing a player's remaining value, you also want to decrease it before you return in every situation. So I just kind of copy and pasted this line here. So we got to decrease it there as well. And so now we're going to get the data, and the data is going to be equal to the serialized plot. So the plot is confirmed, like it's good. So we can serialize it, and that's it. So we just call that function. And it's nice and convenient that this serialized plot is a separate like local function, because it's a pure function, meaning it's not dependent on its environment. It just takes some values and turns it into more values. And that's good that we can kind of abstract that away. And so now, after we serialize the plot, we can just destroy it. And then we can also go to the plot spawn pool. So we can say local plot spawn pool at the top. Equals require script.parent.plot spawn pool. There we go. And then down here we can, below, after we destroy the plot, we can do plot spawn pool dot return player. So since the plot spawn pool doesn't really care about the plot, it just cares about the player who rents out the plot spawn, we can just return that spot and it'll handle it for us, which is great. And now, after the plot gets destroyed, we need to actually save the stuff. So we're going to say local success error message equals pcall. So pcall basically wraps a function, so like if it errors, like there won't be any issues. So it's like the equivalent of like some try catch in other languages and stuff like that. So we need to here like actually save the value, but we haven't defined our storage stuff yet. So let's do local data store service equals game get service data store service, and then we're going to say local plot store equals data store service get data store. Lot store. Okay. So we have the plot store, and this is just a key value data or key value pair data store. So we set a key to a certain value. The value can be like basically whatever we want. That's like a primitive type. So like integers, strings, tables, stuff like that. So that's what we're going to do. So we're going to say plot store set async, and we're using set async instead of update async or like any other method, just because we don't really care what the data was. We're just setting it. In an actual production game, you probably want to do update async because it takes into account what's there before in case stuff fails, but this is fine for us. So we're going to set async to the player.userid as a key, and the value is just going to be data. So we're basically just saving this array of objects, or not objects, shoot, that's JavaScript, of tables that has a name and Z frame, which is an array. So we're basically just saving that in our data store underneath the player. We're using the player.userid so we can access it later once they join. And we're using the user ID, not the name, because the user ID will not change. The player can change their username, but their data should stay the exact same. So, if not success, then we're going to warn string, and this will be good for debugging purposes, or warn error message. I don't know why I said string. But when this is not successful, the error message will be populated with the actual thing that went wrong, and we're going to do that. And notice how here, player remaining comes after the saving stuff. So we need to make sure this is done before we actually tell the rest of our code, which I'll show you why this is important later, that you can like return. But here, when we return early, like we need to decrement the player remaining, because like we don't want our code that'll be waiting for everyone to save to like hang forever if something fails. Okay, now let's go to our load method. And here, it's gonna be a similar story, just in reverse. So let's start off by saying local success data. I spelled local wrong. Local success data is a array of object infos, or a table of object infos, equals pcall function, and then in here we're going to say return plot store get async play. Player.userid. So basically, since we set the player.userid below, and we're getting it here with just the player.userid, and we return it. So when we return inside a pcall, it populates the second argument, or second return value. So the first one is whether it's successful. Second is either the error if it went wrong, or the data if you return it. So it's gonna look kind of funky, but we're gonna say if not success.
Understand now. Success.
Then warn data, even though data and the like good case shouldn't actually be that, but we have that, and then we just return. So, and also again, we're gonna copy paste this up here, and we shouldn't actually be that, but we have that, and then we just return. So, and also again, we're gonna copy paste this up here, and we need to increment the player's remaining value, because like here, because just like down here when we abort early, we need to decrement it. Here we need to increment it, because if we don't, then it'll lead to some funky issues, because the actual, like the save won't go through, because it'll think there's 0 players when they're actually one player. Yeah, it'll be an issue, so we have to do that, pretty sure. And then below that, we're also going to need to actually check if not players get player by user ID. And actually, I don't have the player service. Okay. Up here, we're going to say local players equals game get service players. There we go. And we have our players now. And we're going to get player by user ID, player.user ID. And then we're going to return again. And again, we actually don't need to increment the player's remaining value, because this is the case. We're handling this case separately as well, because this is the case where we actually load the player's data, but they leave before we can actually make the plot. So this led to issues, and I think some of my games, and I think even the Tycoon series that I made, where people would join and leave instantly, but their plot would still be there, because this data retrieval takes time, and in that time, the player can just leave. And so we obviously don't want to increment the player's remaining value if they're not there, because this basically checks, are they here? If they're not here, we don't care. Like, we're leaving early, because like that could lead to a lot of issues, and so we're definitely gonna need that. But after that, okay, we're chill. Like, we can actually load the data. Let's do that. So we're gonna say local plot equals plot manager dot spawn plot. So boom, plots get spawned, and we spawn that with the player, and then we're gonna say if data then. And again, this is another like defensive tactic, because like we need to know like if the data is there. Also, this auto-generated text is actually sort of accurate, but we're going to do it ourselves. So we're going to say for blank object info in data do. So we're going to go through everything in data. I'm going to say local object equals placeable objects. Well, we need to get placeable objects first. So say local placeable objects equals, where is it? It's in server storage. No, it's in replicated storage, but yeah. Equals, actually, we're going to get replicated storage separately. So we're going to say local replicated storage equals game get service replicated storage. There we go. I say local placeable objects equals replicated storage dot placeable objects. There you go. So we have our placeable objects, and we need to get the object. So we have the name of the object. So you say placeable objects brackets object info dot name, and then we're going to clone it. And note how we're using the name. So if you change the name of your objects in the middle of developing your game, this will not work. This will break. You either have to do a migration or define a special ID. Just like how a player has a user ID, you could add an attribute to every object that is an ID value, and that will persist independent of the actual name. But for our purposes, like, a name is just fine, and like really, it's all under the hood. So if you name something wrong, like, just leave it. Because if it's saved in the database, like it is a lot of work to do a migration, so I would just leave it. So we get the object, and we're saying local relative CF, relative C frame equals C. Frame dot new, and we're going to do table dot unpack object info dot cf. And note how we're using this type, so it gives us auto-completion on the actual object info, which is wonderful. So that's that simple. The deserialization is literally just unpacking each individual like C-frame array value and just putting it into a C-frame, because C-frame.new has an argument, or has a constructor, that takes all of the values. Well, this takes a quick review. Here we go. So this is the one that takes all the values that you saw earlier, except in this case, we're actually like building a C-frame out of it. So it just handles it like that. So as long as we keep it in this like universal number format, like it'll all work out fine. So now we're gonna say object pivot to plot get pivot to world space relative CF. So basically now we have the relative CF. We need to get the plots pivot and then get that in world space. So like this relative CF is relative to the plot. We need to convert that to world space and then move it there. And now we can say set object dot parent equal to plot dot objects. And we're setting this after we pivot it, because pivoting, like moving stuff like wallets in the world, is more expensive performance wise than just doing it after. So pivot to here just kind of like changes numbers, and we actually parent it so it appears in the world. And that should be most of our data serialization out of the way. So one thing is like we have a couple more steps before we can actually test this. And if we were to test it now, even if we enable API services, actually let's do API services now. So let's go to security, and you can click enable studio access to API services, and it says enable studio access, so stuff such as data stores. That's what we need to test this in studio. A lot of people like don't recommend to do this. Like you have like a actual place where you test it, but for our purposes for this video, it's perfectly fine. So we're gonna save that. But even if we test it now, we might not get stuff that's like good, because when you like close out on studio, sometimes the game just shuts down early. It doesn't wait for you to finish. It doesn't wait for your data to save. And that's where this player's remaining dot value is going to come in. So we're going to make a function, say function plot storage dot wait or save, and this is going to basically be a busy loop. So we're going to say while players remaining dot value is greater than 0, do, and we're going to do players remaining dot changed wait. So basically, if there's one player left, we're going to wait until this value is changed, and we're going to assume it just decreases, because everyone's going to get kicked out, because the game is like, hey, like the place is closing down, like everyone out, and it'll be like, okay, and it'll save it, and it'll wait, and it'll save it, and it'll wait. And we can actually go bind this to a function that will do that for us. So let's actually bind our functions now. So let's go into server, and you'll note we have player added, which goes to spawn plot for the plot manager, and plot managers, we can actually change that to our plot storage. So local plot storage is require script.parent.plot storage. And basically we're going to say player added, we're going to connect plot storage dot load, because load also deals with the plot spawn. So we're going to say, and also we're going to say players removing connect plot storage dot save. So when they come in, we load. When they leave, they save. And another thing we're going to do is we're going to do game bind to close, and we're going to bind the function that we just created, plot storage dot wait for save. So as you can see in the little description, it says binds a function to be called before the game gets shut down, and it'll wait for it to finish. So we can yield in this function, which we're doing. We're saying, okay, just wait until we're done, and then you can shut down. So the game will be like, okay, like I'll wait for you, and it'll be like, okay, cool. Let's save everyone and let's like deal with it, and that'll be great. So, fingers crossed, everything works. Let's try it out. Who knows? Okay, so we're in the game. Build stuff. Leave. Note how it took a second to actually leave the game. And we load in again. There we go. Ladies and gentlemen. And will you wall like so to enable student now we can say set object
Studio, bro.
parent.
For now, you're in. Someone like you should already know what it's like. The minority tribes.
Here is the world's most expensive pitcher, valued at $325 million, Yamamoto Yoshinobu. But he had a small and ordinary physique. Instead of weights, he just did handstand and flexibility exercises, and at the training facility, he always threw a javelin. However, now even the world's top hitters have begun to emulate his training methods. How did this seemingly small and frail boy manage to become the world's most expensive pitcher? We can find the answer by delving into his life's journey. In 1998, Yamamoto Yoshinobu was born in Okayama Prefecture, Japan. Because his father loved baseball, games were always on at their house. Yoshinobu naturally started playing baseball from the first grade of elementary school.
名前だけでいいんですか？
はい。
インベパウルズの山本由伸です。
はい。
He was just an ordinary player, nothing truly outstanding, who played various positions as required by the team.
特別すごいなって言って誰も思ったことないと思います。本人も含めて。
Yamamoto himself had never imagined he would become a baseball player. In fact, his dream written in his elementary school yearbook was to be a salaryman. His middle school days weren't much different. When the team faced a pitcher shortage,
It's just 42. Okay.
see in the little description, it says binds a function. This value is changed.
User ID.
And we're going to
Ah, shit.
assume it just decreases. Because everyone's going to get kicked out because the game is like, hey, like the data stores, stuff like wallets in the world is more expensive. Performance wise and just doing it after. So pivot to here just kind of like changes numbers, and we actually parent it so it appears in the world. And that should be
Return data. Object. Objection. Yes! Bitch. I fuck.
There. All we did, that. We have data storage. I'm actually very surprised that worked because I was recording for this entire time. I didn't check any of my code. But this works. There might be edge cases. I don't know. Like, I've done this for a couple years, but testing this stuff in production is hard, especially when you're like me and you have no like popular games anymore. So let me know if you run into any issues, but the idea is there. So basically, to recap, all we did is incorporating defensive programming and serialization stuff. We're able to load the player data, deal with it, make sure that we only increment the players remaining when we want to, because this value is used down here when we want to actually prevent the game from shutting down early and preventing people from saving. Because if you did not have this wait for save, testing this would be hell, because when you would leave the game, it may save, it may not save. It's just a hit or miss, and like that gave me so many headaches when I was dealing with that. But using the display remaining value, you can actually do that. And also, whenever you're dealing with stuff like set async and get async that actually block the thread, you need to check the conditions after. So in our case, for save, it's pretty simple. But for our case here, when we're like loading the data, we have to check if the player's still there after the data is loaded. And yeah. So I really hope you enjoyed this video. This is probably this probably is the most useful video in the series. Like, we're kind of building up to this. So using this knowledge, you should be able to make a system to save any number of arbitrary game data values that you need for your game. So I really hope you
a gum pistol and like catch people that are like farther away from you, just to like start a combo, you can do it. It's also just an amazing combo extender though, and it does so much damage. It's just a great move. Now you get key strikes from the Android raid. That's how you get key strikes. Other than that, I do think that that's probably it for the key video. I think those are all the best key moves in the game.
Some dumb shit, man.
Neo Tri-Beam is a funny gimmick move, because it kind of just lets you do this. Just one-shot that guy, but as you can see, it took all my health away too. So a lot of people use that with like absorption on a Majin, or they use special beam cannon on a Majin. They use absorb and then special beam cannon or Neo Tri-Beam, and it's just extremely overpowered. What other